Okay, let's try this together. First, the transient solution is the complementary one. Complementary solution is when you set the right side as 0, right? Oh, but before I do that, let's write down the differential equation first. So L is 2, R is 6, 1 over 0.25 I equals to the derivative of 40 cosine 3t. So I have to differentiate this. And 1 divided by 0.25 is 4, right? So you have 2i double prime plus 6i prime plus 4i equals to negative 120 sine 3t. Because of the chain rule, 3 comes out. Right? Okay, now, it's perfectly okay to solve as is. So to find the complementary, you just set the right side as 0, and you find the solution that satisfies the version with the 0 on the right side. That's called the homogeneous solution. And you can also find the steady periodic, which is the particular solution. By using the method of undetermined coefficients. But before you do that, a wiser thing to do is to see that all of these numbers are even, right? So what do you want to do? You want to divide by 2. Okay, so you want to divide everything by 2 to write down I double prime plus 3i prime plus 2i equals to negative 60 sine 3t. Now these two equations are exactly the same thing. Anything that solves this one will solve that one. Anything that solves this one will be solving this one, okay? So, although it's not necessary to divide by 2, if you divide, it just simplifies your calculation. Okay, now with this at hand, let's try part A. Part A, you set the right side as 0, so you're looking for the solution of this equal to 0, and therefore you write down the characteristic equation r squared plus 3r plus 2 equals to 0, which factors as r plus 2, r plus 1, which gives you r equals to negative 2 and negative 1. And that says that x, no, I of t, that says I complementary of t is equal to c1 times e to the negative 2t plus c2 e to the negative t. And of course, you could switch these two around, and it's the same thing. So either that one or negative 2 here and negative 1 there. You have switched. All right, so that's the answer to part A. And right now, C1 and C2 cannot be determined because the initial conditions are not given. I0 and I prime of 0 is not given. And even if you did have I0 and I prime of 0, you won't be able to get C1 and C2 yet because you don't have IP, because the entire solution is complementary plus the particular, and only to that you have to put in the initial condition and find the C1 and C2. Okay. Yeah, but let's not go that far. Okay. All right. Now let's do part B, which is to find the particular solution by the method of undetermined coefficients. It looks at this right side. We're trying to solve this, and it looks at this right side, and you just want to put whatever you have on the right side, and also the derivative of that. So you have the sine and also the cosine. You need the cosine and the sine. And because I say it this way, it seems like you want to write it as a sine 3t plus b cosine 3t, but that doesn't go well with the part C. So whenever you have sine and cosine together, always put the cosine first, okay? Cosine 3t plus b sine 3t. And the reason for that, it will be clear when we get to C. It's just that the formulas that we remember for part C is made for this situation, not the other way around. So if you have it around, the other way around, it will be confusing, okay? All right, so that's what we have, and then I have to differentiate this because I have to plug this on the left side so that it matches with the right side. So I have to differentiate this, which is negative 3a sine 3t plus 3b cosine 3t. And differentiate again, which is negative 9a cosine 3t minus 9b sine 3t. And then because I'm plugging it into the left side, I see that the coefficients are 1, 3, and 2. So for this one, I need to multiply by 3. For this one, I have to multiply by 2. And then if I add them up, I get what I want. So what I want is I p double prime plus 3i p prime plus 2ip. And that's going to be, let's see, 2 times a. And there's a here's a cosine, here's a cosine, here's a cosine. So it's 2 times a, and there's not negative 9a. So adding this one with this will give you negative 7a. And then 3 times 3b will give you 9b. And this will be the cosine 3t. On the other hand, if you track the sign, there's a sign, there's a sign, there's a sign. So 2 times b and negative 9b. Negative 9b plus 2b would be negative 7b. And then 3 times negative 3a, that's negative 9a sine 3t. All right. Then I need this to equal to what? It has to equal to this right side, right? So this here has to equal to negative 60 sine 3t. Okay, so what does that mean? That means negative 7a plus 9b better be what? Equal to? No?
Oh, 0.
To be 0 because that's the cosine one, right? Okay. And then negative 9a minus 7b should equal to?
Negative 60.
Negative 60. All right, great. And there are many ways to do this, but let's just solve this for b. So 9b is 7a, so b is 7 over 9a. Plug it in here, so you get negative 9a minus 7 times 7 is 49. So 49 over 9a equals to negative 60. There's lots of negatives, right? So let me find room here. So what I'm going to do is I'm going to multiply by negative 9. So I don't like negatives, I don't like fractions, so I multiply by negative 9. And the result is you get 81a plus 49a equals to 9 times 6, 540. 49 plus 81 is 130. Actually, it's plus, right? And then you divide by 130, which gives you, and zeros cancel, so a must be 54 over 13. And then b, as written over there, this is 7 over 9 times 54 over 13, so it's 6, so you can reduce, 6 times 7 is 42 over 13. Okay, so what's the answer to part B? So the answer to part B would be IP, the steady periodic solution, is 54 over 13 cosine 3t plus 42 over 13 sine 3t. Is that good? All right. Okay. So this is the answer to part B. That's the answer to part A. Now let me erase this part now. Let's try to do part C. Now for part C, you need formulas. And the formulas are, if you have A cosine omega t plus B sine omega t, the amplitude C is square root of A squared plus B squared, and the angle, phase angle alpha is tangent inverse of B over A plus angle theta, where theta, depending on which quadrant you are at, you may have to modify it slightly. That's your theta. I don't really care if you use degrees or radians. However, if you use degrees, these should be changed to 180 degrees and minus 180 degrees. Okay? That will be a source of mistake. And another thing is that while I don't really care about units, this being a math class, I'm not that strict with units like your engineering professors or physics professors are. However, I am strict with the units when it comes to angles, because that's a mathematical object. So if you write your answer as degrees, let's say your answer was like, say, 30 degrees. If you just write 30, I'm going to take a point off. It has to be 30 degrees. There's the small circle. That's important. Okay, so it's okay to write your answer in degrees or radians, but make sure that you don't forget the small circle for degrees, and also to change this with 180 degrees. So, okay. All right. So in our case, A is this and B is this, and that's why I said don't switch this around. If you switch it around, then your definition of A and B will be switched around. Okay. All right. So now we can find the value of C, which is square root of 54 over 13 squared plus 42 over 13 squared. Did anyone get the answer for this?
5.26.
5.26, okay. Yeah, I agree with that. I remember getting that answer yesterday when I did it. And then for the angle alpha, it's a tangent inverse of 54 over 13 over 42 over 13, but division by 13 doesn't do anything. They're both divisible by 6, so it's...
I thought it was 42 on the top.
Yeah,
Oh, it's 42 on the top. Thank you. It's B over 8, right? Yeah. So it's 42. The 13s cancel out, so it's really 42 over 54, which is same as tangent inverse of 7 over 9. And by the way, because they're both positive, if they're both positive, then you're in the first quadrant, so you don't have to add anything. It's plus 0. So that's what you need. Can somebody tell me what the value of that is?
37.87 degrees.
37.87. Don't forget this small circle, okay? So we already have the amplitude, which is the C, and also the phase angle, which is 38.87 degrees. How about the period? How do you get the period? What's the formula for period? T is 2 pi over omega. Yeah, and to get the frequency, you'll be doing 1 over t, right? So it'll be 2 pi over 3, that's your period. And frequency would be 3 over 2 pi. Frequency is measured in hertz. Okay. And then, so these are the answers. That's the amplitude, phase angle, period, and frequency. And because it didn't ask you to write the answer in any form, that's the answer. But however, let me ask, if all these are obtained by putting this into single cosine function, right? The reason we get those formulas is by putting this into single cosine function. So what would you get if you put it as a single cosine function? It'll be 5.26 times cosine of 3t, and then what? Minus 37.87 degrees. Yeah. So don't forget there's a minus for the phase angle. And that's because when it comes to graphs, if you subtract, it moves to the right. Okay, so that's why you have this minus alpha. Right?